And my microphone was off. There you go. Hello. Hi, Kakalakjo. Yeah, thank you. I just realized. I'm so not prepared. I just washed my hair, by the way, so that's why I have this thing on, just to dry my hair a bit. So just try and ignore it. Um, my dog is super barky right now. Right on cue. Fantastic. Okay, I have to pick her up. I'm sorry. I'll be right back. I just leave everything on. Ah. All right. I am back. Okay. Will you quiet down now? Thank you. Okay, well, so as I said, I forgot to change my stream schedule on Twitch, so this morning's stream wasn't really planned. But it gives me a good opportunity to do some more code cleanup, to finish up the syntax tree parsing, right? I actually worked on this assembly a little bit off stream. Ooh, I'm out of breath. What the hell? I worked a bit on the off stream on the syntax tree parsing just to finish it up because, like, I was stuck on this for way longer than I intended this to go, right? Just because I was unsure of what to do and things like that. So, but I think I finally came up with something that I like. So I'm just going to continue with that, even with like error handling and this stuff. And yeah, just a bit of cleanup this morning, and then I will probably stream later in the day where I move on to a bit more exciting things. Maybe we can even get to code gen. Maybe. I don't know. There's still a lot of things to do. For example, making it compile, because at the moment everything is so utterly broken because I shifted things around and I created this new tree.h file where the whole syntax tree parsing is in, right? I want to flip that out into an .h and .c file, right, just to separate it a little bit. This is not quite done yet, but this is what I was working on yesterday, and as far as I can tell, it should be all right. What's going on? Oh, I'm on the wrong machine again. Classic. Okay. Zoom in a bit. So at the moment, everything is utterly broken. There you go. A shit ton of errors. I love how it never tells you how many errors you actually have. But yeah. And again, I have my dog on my lap, so excuse me, this will be a bit awkward. Oh yeah, lay down on my hand, why not? Okay, but basically I have this syntax node type enum now, which describes all the different syntax nodes that are possible. And then a syntax node just looks something like this. It has a type. It has the column in the current line we're in and the byte position. And then just a void pointer, which is the data of that syntax node. And that data can vary depending on what this node actually is. Right? A syntax node is only, I'm only parsing line by line. That's why the line number is not in here. That will be stored somewhere else. Okay. Then I have a little method here which just creates a new a new node on the memory arena right here for the lexer, and then just sets the column position, the type to what is passed in, and the data will be automatically set to 0. And then I have specific nodes that I can create. For example, a directive node. A directive node sets the data to the directive keyword, right? A directive is just a keyword. So this is not a pointer. We're kind of abusing the pointer because a pointer is 64 bits and our keyword is 32 bits. So we can just assign this and pretend this is an address that we're assigning, but it is actually the value. So, it's just so I don't have to create a separate type for it. Okay, this is perfectly fine code. It is a bit head scratching, but it does. It works, right? Then I have this. Here we can check whether a node is a directive, right? This is just a basic checking the type to see if it is a directive. And then I have a get directive value. So you pass in the node. So the way this would work is you would check if a node is a directive, then get the directive value, right? And it just does what it needs to with the data part. And this is like the basic makeup of all of the nodes. So an operation node, same thing, right? I have a function that can create it. Again, an operation is just a keyword, so we assign that to the data. We can check if the type is a keyword, and then we can get the value. Same with registers, same basic thing. Then I have an immediate node. Now, an immediate node an immediate is like a value, right? Like an integer, so hexadecimal or binary or a decimal number. And same thing here, I just assign the number to the pointer, pretend it's an address, right? But same makeup. Something to create the immediate node, to check if it is an immediate node, and then to get the value. The value is a bit different here because I'm already casting it to U16, as that is the maximum value an immediate can actually have. So then unary operators are a bit more interesting, right? So here we have unary operators essentially. Where should I start? Let's start here, right? So it has the same makeup. It has the function to create the node right here, except you see in data there is a bit more happening. I'm actually calling unary operator right here, and we'll go into that in a second. But then same if, to check if it is a unary operator, and if it is, you can retrieve the data. Now you see the data is a unary operator T, so this is an extra struct, right? And this is the unary operator struct. I need to have a bit more information on unary operators. For example, I need to know what kind of type it is, so if it is plus, minus, or a binary not, right? And then after a unary operator, you can have any kind of syntax tree, any kind of expression following, right? Because you can have something like, okay, the basic one is -3, right? So this would essentially mean that this syntax node right here just resolves to an immediate value of 3. But what if you have something like, let's say, 3 plus 2, right? So you have 3 plus 2, but then you negate the result. That is perfectly valid, right? So we need to kind of have the ability to pass any expression and put that as the value for the unary operator. So this is why I had to create a separate struct here. And then this function right here just assigns it, right? So this is creating the unary operator struct on the arena. Because we already have the unary operator, we call lexer advance to advance to the next character after it. So in this instance, it would be the 3, right? Or it would be the, so in this instance, we want to advance to the next character here, which would be the open braces. And then we call expression node leave. Now this is the whole parsing of an expression node, which means, we get to that later, it's the function down here, but this is essentially the start of an expression parsing, right? So this is how unary operators are implemented now. Then we have strings. Now a string node, It's a bit annoying. So as the data, I'm just storing a pointer to a string structure, which is allocated on the arena as well. And then I copy the string, right? So this string right here is not a copy. It's actually just a pointer into the file that we opened and where we're reading out the string from. But as soon as we're getting to the node, and because I sometimes might have to hold on to nodes if something is unresolved, I need to take a string copy right here, right? So this is the moment where I actually need to copy data. Same thing for the string nodes, so you can check if a node is a string, right? And then you can get the string value. Then same with the identifier nodes, they're also just a string, right? So I have syntax node type identifier. There I'm also taking a copy of that string, but I already made it to do here because symbols, or identifiers rather, well, we kind of want to have a dictionary of them, right? So there is no need to copy them around if we already know what it is. We might as well just refer to what we already have in memory, right? Just to reduce the footprint a little bit. String values, like here, those are very rare in the assembler. They will only appear probably for the header, right? Maybe someone wants to add it as a data point, but I don't think that's really that good of an idea. But they will probably just appear in the header for like the Game Boy title and, you know, that kind of stuff. Actually, just the title. Yeah, I implemented a whole string type just for one use case. But hey, needs to be done, right? So, and identifiers, like I said, they will be largely the same, right? So, and used a lot. So, for example, these ones, right? This would be an identifier, and you can imagine you might want to refer to it in many places here, or tiles, for example, right? So all these labels and things like that. So I can actually save a bit of my memory by avoiding the copy here if it's already known, and that we will do with the help of a dictionary structure. But that is quite involved for now, and I mean, it works with just taking the copy for now, so I'm just going to do that. But that is definitely something to do for the future, right? We're not using the dictionary at the moment, but I want to. As you remember, I went through the stream where I built this whole edit distance thing to find, you know, to have later on error messages where we're like, oh, did you maybe mean to type this instead of what you typed there? Because you could have a typo, right? So it would be nice for the assembler to actually tell you that. But this is largely unused at the moment. We just implemented the algorithm here on stream and that's it, but haven't used it yet. But that's for future cases, right? Then same thing, you can ask, we already went through that, never mind. Okay, so then there is brackets. Brackets have a bit more information as well. So here's the brackets node, right? You can create it. The brackets node also takes a syntax node type because there's two types of brackets. So there is round brackets and square brackets, right? So I have this little macro here that overrides it and passes in whatever you need already. So this is how you create a brackets node, depending on what it is. Then you can ask, is it a square brackets node? Is it a round brackets node, right? And then you can just request the brackets value. Now, the brackets value is this little struct right here. After an opening bracket, you can have any kind of expression. So again, we need to kind of hold on to a whole syntax node, which will describe that whole expression, right? And we just call this inside. And then there's a little flag in here to indicate whether the brackets are closed or not. I mean, we know they're open because we have a bracket structure, but we don't know if we have a closing bracket, right? So I just made this little flag. And this is how you create the brackets. So you put the brackets struct on the arena, then you advance the lexer, right? Because we want the next character after the first opening bracket. Doesn't matter which kind of bracket it is. And then we just go through the expression node because we want to parse a whole expression, right? And then once the expression node is done, we can figure out whether it is closed or not by asking if the current token that we're at is actually a closed square bracket or a... I should have named this round bracket. This is annoying. Okay, if it is a closed square bracket or round square bracket, right? And if it is none of these tokens, so if it is not, you know, one of these or this one, then the brackets are not closed, and this will be set to false. Okay, so those are brackets. Then we have an invalid node, which is, well, it doesn't hold any data, right? It's just a node that's basically empty. Now, this can be, actually, I thought about this, but I didn't add a to-do. So keep one instance always in memory and reuse. Right? So this is just an indication for the later parsing that there is something that is invalid, but we already printed an error out of this, so just ignore it, right? And the reason why you want to have this instead of just, you know, leaving the syntax node empty is because if something is empty, that means something is missing, right? So that would be another kind of error where you then say, hey, missing yada yada in this position, right? Let's say, for example, you have LD comma A, right? Then here, there is an operand missing, right? So what you would want to say is you have a missing operand in this location. But if there is something that's invalid, like, for example, a binary number that, you know, suddenly contains a number 2, which is illegal, right? Then you can't just pretend that this is not there, because then you will also get 2 errors. You will get the error for, like, the binary number is invalid, and then, hey, it's also missing, which doesn't make any sense, right? So this is why you make this an invalid node. So later on, when you parse and account an invalid, you know, okay, there is something there, but it doesn't make any sense. But we also do not need to report an error for this. We're just going to ignore parsing further on. Okay. So then we have binary operators. Again, we have a binary operator type enum here with all the different binary operator types that are possible. And then a binary operator essentially just has the type and then a left and a right-hand side, right? And left and right can be whatever syntax, whatever expression, right, you want. So it's just a syntax node. Where do I start with binary operators? Because that is the most complex thing, to be honest. That's all right. Let's start with the node, right? So we want to, at some point, we know the next node should be a binary operator node, right? So we check the current token is a binary operator. If it is not, we return the left-hand side already. So the way the parsing works is like if you have 3 plus 4, right? You start from the left side and go over to the right. So the left expression is already parsed, so we already know it. And then we check whether this is a binary operator or not. And if it is not, right, then this expression is done and we need to return back the left-hand side and do whatever we need to do with it. Then we also check precedence on binary operators because, well, it could also be like something like this, right? Then you need to check like what has higher precedence and then sort stuff that way. So if the precedence if the next binary operator that we have here has a hang on, has a lower precedence or is equal to what we have here, then we already give up, right? So we just return the left again. And then if the precedence is higher, you just create a new node, right? And you say, well, this is a binary operator. And then we just call binary operator, which is this little fellow right here. And all it's doing is it's putting the binary operator struct onto the arena. We're setting the type. We put the left-hand side on the left-hand side. We advance, because at the moment the tokenizer is on the binary operator, right? And we want to advance to the next one after that. And then we just call expression node to basically continue parsing the expression. So the right-hand side of the expression, right? So if you have 3 plus 4, we are now in this stage, we advance over to here, and now we need to parse this expression. And this expression could be like braces, for example, right? Something like this, if you wanted to. Doesn't matter what it is. Okay. And then finally, the whole meat of the situation is the expression node, right? So this is where you would start with parsing an expression. The first we're calling expression node leaf, right? Which is parsing the expression node leaf. So think of it as the left-hand side of an expression, right? Even if you just have a 3, that is the left-hand side of an expression, which then becomes, you know, something else. And what can it become? Well, we check if it is a register and then, you know, return a register node, right? If it is an open bracket, we call, well, the function to parse open brackets, which you then know will go into parse expression again. So this will actually start a new expression parsing. So it's kind of recursive. So that's a bit hard to get through, and it's hard to explain. But maybe we can step through with the debugger at some point. I mean, I probably have to anyways, because I'm sure there is some bugs in there. As I said, I haven't been able to run this yet. I just hacked it out yesterday off stream. Yeah, hi. Why are you looking at me so okay. Hello. Right, my dog had to smell my mouth for some reason. Okay. Then we just check if this current token is a number token, right? And then we return an immediate node because this expression is just an immediate value. We can check whether this token is a unary operator, and then we go into the unary operator parsing that I showed you up there before. Same for an identifier, and then same for a string. And there is no error handling. I'm not checking whether it makes sense to have something like, let's say, string ABC plus 1, right? Like, what is that? That is illegal, right? But that is not part of the syntax tree parsing. Because for all we care, this could be valid for some operations if we ever want to implement this. I don't know, right? We're just building the tree. Later on, when we go through like parsing through the operands and stuff, those will handle these kinds of situations where they then will, you know, throw down a syntax error saying you cannot have a string within, you know, an arithmetic expression or whatever. I don't even know what to call it, right? So anyway, those are all the valid tokens. And then we have invalid tokens. So a token can already be invalid, right? So for example, if the number parsing failed, or if, what was the other one? If we have a directive that's unknown, we return invalid token, right? In this instance, we just create an invalid node because we already reported the error in the tokenizer for the invalid token. So we just need to make sure that, you know, we don't report it as missing or anything like that. By the way, ads will start in about 3 minutes or so. You know what? I'm going to snooze them for 5 minutes. There you go. We have a bit more time. Because I'm in the middle of explaining. So we just return the invalid tokens. So, you know, later on in the parsing, we know that there is something that already went wrong, and we just don't need to report it. I don't just return null because, as I mentioned, that is kind of a special case, right? Because that is something missing. Now, if the token is a directive within an expression, we already know that that is bogus, right? So I could do the same for strings, but then some operands allow strings So why not just have them as expressions, right? That is completely fine. Also, what if someone wants to add braces around their strings, for example, like this? Like, I mean, does it really matter? No, it's fine, right? We're just gonna pass those brackets and just put the string in there, and that's it. Like, let's not be too strict about this, right? But a directive can only be at the beginning of a statement, right? At the beginning of a line. So if we ever encounter this in an expression, we know this is a syntax error. So we do exactly this. We report a syntax error, invalid assembler directive. Assembler directives only appear at the beginning of a statement. Can only appear at the beginning of a statement. By the way, I have an idea for this error thing because I don't like how I put the error messages like in this code. So whenever I want to change the error messages, I have to look through all the instances. I want to make the error handling a bit better so I can just add specific error types and then maybe an error number, right? And then have the strings all in one location. So I can just need to change them there in one place. Instead of having to look through the code of, oh, hey, where is this error being thrown out, right? I think I made it to do for this, right? I did not. Other strings should not be in the parsing code. Have them in error.c instead, and parsing numbers to indicate what kind of error, or enum, right? So something like this. So the other thing is an operation. If we have an operation within an expression, that is also not valid because, you know, operations can only appear at the beginning of a statement, same as directives. So we throw an error here as well. Then we have a binary operator. Now this is for instances like, let's say you have 3 times 2, right? So 3 times, well, this is illegal, right? So this is what it would read. So invalid binary operator. That's just the syntax error you're getting. So, and for all these errors, we also return an invalid node because, again, we report the error and just say this is an invalid node, right? And then it would continue with the parsing of the expression. So this would be part of a separate tree, probably. There might be another error thrown for this one then, which is fine, I think. And then label. So label is label definitions, right? And label definitions are only allowed at the beginning of every line. So if they appear anywhere else, that is also a syntax error, essentially. So we can already report that. And then there is some ignore tokens where we just return null, and that is for end of file or new line. We just return empty, right? Because, well, there is no expression because we are at the end. I also return empty if there's a comma, because a comma indicates the end of an expression. And it basically, you see that once we go to the operand parsing. And if we have a close round bracket or a close square bracket, so one of these things right here. Great, thank you. So either one of these, I'm gonna ignore those as well, because these are handled by the calling code of the expression. Because usually, if you encounter one of these, it means you already have one of the opening ones, right? Usually. So, and with these, those get handled in the, what was it called? In the round brackets node or square brackets node, right? This one calls parse expression. So it basically is treated as a new expression. And then once the expression is done, we're going back to this code right here, the calling code. So this is where we consume the end token and stuff like that. So we're not doing that in here. And this is also so you can report empty stuff, because what if you have, let's say, 1 plus and then nothing, right? Well, we would read 1 plus, and then for the right side, we would read this one, but we're just pretending that this is the end of the expression, which means this is missing. So now we can correctly report a missing number, as opposed to saying, oh, invalid token, close square bracket, right? It's a bit nicer error handling, I think, for this one. I hope, at least. Okay. So this is expression node leave. And then we have operands, right? So basically our structure is something like this. We have labels, right? You can have as many labels as you want. Then we have an operation, right? Which is basically an instruction mnemonic such as LD, add, or whatever, right? And then you can have operands. And every operand is... Actually, this is not only an operation, can also be a directive, right? An assembler directive. But an assembler directive also can have operands. And you can have as many operands as you want. And they all are separated by a comma. So, and an operand itself is just an expression, right? So this has an expression. This has an expression. And this potentially has one, right? So I have this operand struct, which contains the expression that's within that operand, and then it points to the next operand that comes after it, right? So this is essentially like the tree. So we have the operand and then the expression tree, then it points to the next operand, which has another expression tree and stuff like that. I think adds are in progress, so I'm going to stop explaining for a bit. Oh, actually, not yet, I think. I never understand that. They have a countdown for ads, but then they don't immediately fire up. So I think you can still hear me. Sorry about that. Actually, in the meantime, I can take this off. Ooh. Well, now I have wet curly hair, but whatever. I just couldn't stand this thing anymore. Should actually blow dry my hair, but yeah, it's not gonna happen on stream, is it? Okay, ads are in progress, so I'll still wait a bit. It's just water, dude. My dog is smelling everything that I handle, so it's like, you know, like having to go through customs. Dog has to check everything. Welcome back. I think the ad break is over. I sometimes feel like a supervillain having like a dog on my lap. I know usually the meme is like with cats, but I mean, my dog is basically a ginormous cat. that does dog things. That makes sense. Okay, well, so let's continue. I think the ad breaks should be over now. So if you didn't see any ads, sometimes it says there's an ad break, but then I check my stream and stuff and there's no ads going on. So I don't know. Maybe you saw me the whole time. I don't know. I just like to wait it out until the little countdown is gone and then just to make sure no one is missing anything. Anyways, okay, so this is the structure, right? So labels, operation, directives, and then you have operands separated by a comma, and then each of these operands has an expression. And this is basically like a linked list, right? I mean, the whole tree is essentially a linked list. But we have the expression of an operand and then the next operand node. Can you stop licking my hand, please? Oh, my lordy lord. Okay. Sorry, I get hugely distracted by that. And this is actually where I left off last time. So this is not finished yet, right? So I'm going to be finishing up this. Can you stop? Stop licking my hand. Okay. Yes, so we have an operand function right here that is able to create the operand structure, right? It's just going to be laid out on the arena. And we need to pass the expression. Now, the expression is passed via operand node leave. Operand node leave basically passes an expression node. And if the result is not zero, no, sorry, if the result is zero, it's going to be one of these potentially, right? Let me just copy it. So it's going to be one of these, right? We don't need to handle end of file or new line. That just means the operand has basically nothing. So there is no operand. And this also has the beauty of the tree. So you either have... wait, how did I do this? Yeah, so you always have an operand struct, right? But if the expression is 0 and next is 0, then you know there was no operand in place, right? So you have no operands whatsoever. If you, however, have a next, it means you have a situation where someone typed something like LD, A, right? So there is an empty operand there. So this expression will be null, but next will be set because, well, there is a next. So you can have an error message specifically for that. You could also have a situation where, let me think about this. Right, you can have a situation like this where someone has load into A, comma nothing. I mean, that is one, but that's basically boils down to this, right? So expression is null and next is null. But also, what if you have comma, comma, right? That would be a valid expression. So you have two operand nodes right here. This one has expression empty, but points to a next node. And that will be just another empty operand. So, yeah. Anyways, so we don't need to handle these. And commas will be handled somewhere else. So we just pass them through, right? Commas will be handled down here in the operand node. However, what we do need to handle is close round bracket and close square bracket, right? So this is the situation now where we have an expression that is just one of these, right? Or this. So what do you do with that? So let's say, in proper example, let's say LD like so, right? Well, because you're passing an operand, so you're in this situation, you now is the time to handle these as syntax errors, right? So this is why I'm checking here, because we would just return null. It could be either one of these, right? It could be end of file or new line. So we need to check the current token. So I have here is token closed round bracket, and then I will throw an error for this one. Well, I say throw an error. I will add an error to the error list, right? And then just return an invalid node for this one. And same for is close square bracket, right? Same thing, invalid node. I haven't added the error messages yet, but essentially you want to report a syntax error here, that you have a trailing bracket without an opening. I don't know. I haven't thought about the error message too much yet, but so, and because we're setting the result to an invalid node, I just check whether this is invalid or not. And if this is no longer null, then we need to advance the lexer to the next token afterwards, right? I have to do this check again because there is end of file and new line, which will just be 0. So I can't just always call advance, and I just wanted to call it in one place instead of in both of these cases. So yeah, whatever. I'm sure the compiler optimizes this anyway, so it's fine. Anyways, and then we just return the result for the node leave, right? And then here on the, so that is the node leave. But here on operand node, so what do we do? Well, first of all, we create a new operand node. So calling this, yep. Then we need to create the operand struct with operand. Operand will call operand node leave to parse the expression, right? And then if the operand is not null, we now need to check that the token at the end of this operand is a comma. So this is what we're doing here. So if the token is a separator, then we do a lexer advance, right? Because we have detected a comma and we want to move past it. And then we set the operand next node to a new operand node. So we're calling ourselves again, basically recursively, because now we need to pass the next operand. I don't quite like this recursive thing. I would much rather have a loop, I think. But I'm not quite sure how to do it yet. And as I said, this code is not finished. I was trying a few things, right? So now we're going into uncharted territory here, and let's figure this out. So, and there's also the question, what if this is not a separator, right? So let's say you have LD into A, and then you have 1 plus 2, something like this, but then you suddenly have a 4 here, right? So we would pass this as an expression and end up to the point where we now go into this code where we want to pass the next operand because we think this is a next operand, right? So we're in this space and we realize this is not a comma. But then what if it is afterwards So let's say we have something like this, comma, again 1 plus 2, right? Essentially, at one point do you give up and just jump to the end of the line? And report no more errors. I think this would pretty much be that situation, right? So if we don't have a separator, we're going to report an error and then just skip to the end of the line. Because it could also have something like this, right? How do you handle these situations? So we would have a 4, 7, 4, 2, right? So those would be all separate tokens that are coming in. And do you really want to report errors for every single one of these instances? Maybe. Maybe you do want that. I mean, maybe we need something like read trailing tokens, right? So report trailing tokens. So whenever we are done with an expression and we don't have a comma, we just say, maybe we can just have a global error message, like not a global error message, what am I talking about? A sort of generic error message where we say, well, everything beyond this point is considered bogus, you know? Or I really go through this until there is a comma or an end of line. I kind of like the idea of doing that. But then it could be a lot of tokens. I can report something like this. Syntax error. Unexpected trailing token, whatever that token is. So the errors usually show the line number, right? They show the column and the byte position. So you know where this error started. So this would report this 4. That would be line, whatever line you're on, and then the column of the 4 and the byte position of this 4. And then I can say unexpected trailing tokens in operand until column and byte. And then have this here, the column and byte of this one, or the next comma, or possibly the end of the line. If it is until the end of the line, I don't need to report these. I can then just say until end of line. That might be cool. Let's do that. We expect a separator here, right? So if let's call this next operand. And if is token separator then we do Alexa advance we can do that. Operand T. So let's take in an operand. Let's call it current, right? So we're taking the current operand that we have, and if we have a comma, I'm already trying to think how to do this in a while loop, maybe, with the error reporting. Hang on. Okay, let's just spell out the clear path, right? So we have a separator, we advance, and then we can say current next is operand node, right? Get the next one. And then what we can return is current next, right? Except this is a syntax node, right? So I have to do that. Is it a syntax node? It is. I mean, everything is a syntax node, yeah. Now, I just want to, because we know the syntax node of the first one, right? So we can do this. We can do, and then we simply cast. No. If current next is null, return null. Otherwise, let's do return current next data, and that will be an operand t. And if it is null, yes, that's fine, right? It just means we don't have another operand. Because operand node will eventually then call next operand. Okay, what do I need? I want an operand node, right? So this should be the calling code. What should happen is read operand, read expression. Then let's call this step 1. Fine, 0. 1. 2 would be read operand, read expression. Check for separator. Then hey, thanks for the follow. What? My ad is about to start. What? Is this an old notification? I might just... Okay, there might be ads in progress soon, I think. I just probably missed the countdown. We'll see. Gives me time to think about this. You're not going to miss much. I'm not coding anything. So, and if, so check separator. If separator go to whatever step if separator consume and go to 1, right? Otherwise, go to 3, and 3 will be loop over all tokens until separator. And report single error. If separator consume and go to 1. Otherwise, terminate. Okay. Let's call this operand node expression, right? Because that is what we're doing here. We're creating the expression node to pass that in here for the operand, right? And then syntax node t operand node leaf is the whole so syntax, essentially this thing. Return results, where we then say results data is operand So this creates the syntax node, right? This calls operand for the struct, which then calls operand node expression, which calls the parsing of the expression. I'm wondering. So I'm treating the brackets separately, but if I do this, error thing where I report any of these trailing things, I might just include the brackets. And then have like separate error message depending on what it is. So I don't need to do this whole thing actually. That might not be a bad idea, honestly. Yeah, let's get rid of all of this. We just need to parse the expression node. Oh, this suddenly became easier. Okay. So we got this. We're calling operand node leaf, right? Where we create the whole syntax node thing. Then we're calling operand to set the data, which calls this, which creates the expression thing. Don't really need to have it in separate functions like this, right? But they're so small, the chances that these will be inlined is very high. So I'm not going to worry about this too much. But if you wanted, you could just put all of that code essentially in here, right? But I kind of want the clean separation for this. And I'm sure the compiler helps out a lot. So it's not like this is a virtual function call or anything. So it should be fine. Okay, but now to this part, right? So we have this part down. So this essentially is part 1, right? So we got this done. Loop in a loop. Could do. Okay, well, start with the leaf, right? Syntax node. First, right? The leaf just takes the lexer. Okay, if first an operand in itself. Okay, see, this is. I really have to come up with something better here. Every time I use the memory arena, it could return 0. And this is virtually impossible with the amount of memory you have, right? I really need to figure out, like, in the arena, how virtual alloc is actually able to fail and kind of come up with something better than just returning 0. because that is the only moment which like this can fail if virtual alloc fails. I just don't like that I have to check for null every single time, right? I would much rather treat this operand as, hey, it's always there, even if this is null. What I could do is I could have like a null operand that's just empty, right? With no expression and no next, and just return that and pretend that's what it is. But I don't know. I just don't like this. Because now it bubbles down to here, where I then have to say first data is also not null, right? And that's just ugly as, you know, insert bad word here. Not bronze. First. As an example, C lexa.c. And what is the function called? I will move this to C, that's why I say lexa.c, but operand node. But it is what it is for now. This is something I have to learn, and I couldn't come up with a good solution yet, but something, you know, it's easy when you use the stack, right? You either have room on the stack or you don't. If you don't have room on the stack, your entire program crashes with the Stack Overflow, right? Arenas are supposed to utilize the heap in the same way as a stack, where you can just push and pop things off of it, right? And it allows for dynamic growing. I mean, the stack kind of does as well. It functions in the same way, right? The stack is just on the heap really as well. It's just reserved memory pages, and then it commits one page after the other, the more you need from the stack. And the memory arenas function in the exact same way. I reserve a bunch of address space, and then just commit a few pages, and if I need more, I commit more and more pages. And if I truly want to handle this like a stack, I should just not worry, don't do null checks, and just let the program blow up, right? But you kind of don't want that. It would be nicer to be able to at least terminate the program and be like, yeah, there's something going on, we can't give you more memory, so bye, right? And then just exit the process or something. But that would require me to work a bit on this interface here and kind of change it, or provide another layer on top of it. I don't know. I really haven't come up with a good solution. I could maybe check out the source code of the RAD debugger and see what they're doing, because they use arenas as well. that might not be a bad idea. Maybe they came up with a good solution. But before I do that, I really want to think about it myself, but not right now. But yeah, I want to avoid these checks. It's just plain ugly. Okay, so we have an operand no leave. And we want to check for a separator, right? Ah, okay. Likely a ban evader. Okay, interesting. Suspicious user, ban evasion. Interesting. Sorry, let me just deal with that. Can I report stuff? Spam. Spam. Ah, thanks for banning Kakalanga. I also made a report. But I mean, it's already been flagged, so. I really wonder what this achieves, like spamming on Twitch. Like, I don't understand spammers. Let me put it this way. I just don't understand what it achieves. I don't understand who would fall for that. I don't get it. I honestly don't. At least it was automatically blocked for chat view. All right. It's good to know. Okay, you need to go. You're very clingy, I know, but like I can't type like this. I'm sorry. I'm sure it's more comfortable for you to lay down there as well. Okay. Whew, I can breathe. Breathe. All right. Okay, do oh, I switched machines again. Oh my god. Do while let's just do this for now, right? I'll just leave it empty for now so it at least doesn't compile or whatever. I don't know what to put in there yet, so so what I want to do is if is token separate actually we are fancy now. Wait, you can have colorful text? Oh, you can highlight messages. Yeah, oh my god. Okay, I haven't looked through all this reward stuff and things like that because, you know, I figured no one really is using that. At least not on my stream. My full viewers. But yeah, apparently custom emotes are also a thing and stuff like that. So I need to look into all this kind of stuff. But it's just all a distraction for now. So yeah, I don't know. I also get ad money now. Yay. A few cents. It won't buy me a coffee anytime soon. Anyways. Okay. I mean, I sort of always want to skip to the next next token. Don't you start. I'm not sure if you can hear my dog, but she's barking again. I kind of always want to skip to the next comma, right? So let's have a function for that. Right. Actually, let me remove all of this nonsense. This is what we want, right? So this is our main stuff. The rest is just me figuring things out. Everything up here is okay, and this is okay. But now, what we want is void. Actually, do we want a void or do we want a boolean so we can figure out whether we reach the end of the line or not? Skip to next operand, right? And here, what we're going to do is while is token separator except is false, Lexer advance, right? So as long as we don't have a separator, we're going to do something. But what we're going to do is add an error, right? So add... No, we only want to report errors once. Sorry. So first what we do is let's record the column. Use 6, yeah, right. I just need 6-bit of data. So let's current token column, right? And then U64. There is a position. And we could actually do a count, right? Let's call it error count. So if this token I cannot use add token error because that would need a token to pass in. So I kind of need to use the more heavy-handed add error, which is okay. So we want to loop as long as we do not have a separator, but also is token end of line. As long as it's not end of line. So end of line, by the way, is just doing end of file and new line checks. And then, yeah, add a bunch of these is token something methods here. Those are all new. Also need to set the precedence properly. Haven't done that yet. Okay. So as long as the token is not end of line and is not a separator, we're gonna say error counts plus plus, right? Start column, start position, and error count. Okay, then we advance to the next token, rinse and repeat, right? And if error count is not 0, then we report an error, right? Okay, we'll get you the error in a second. So now we could either have a separator or we could be at the end of the line, right? So we kind of need to figure that one out. So return is token separator. Let's just do another check. All right. So if the token is indeed a separator, we have managed to get to the next operand, right? So we just return true, and if it is not, we just return false. And in the meantime, we skip all the tokens, right? We might jump over this one. Then we check the error count. And add an error. I think I need to use add source file error now, because I need the file pointer. No, that will use the current. No, I fully need to use add error. Ugh, it's gonna be ugly. Okay. So this is Lexa file file name. Then Lexa file line. Then start column and start position. Okay. Syntax error. Oh man. What if it's just one, you know? One invalid trailing tokens. tokens. Until we can say column LLU and I think I named this byte, right? Byte, yeah. So basically this. And then that would be Lexa current token column and Lexa current token position. Except I forgot about the arrow count. What don't you like? Oh, we have ads. Okay. I'm gonna wait a bit. Ad break ends in 1 minute and 10 seconds. What don't you like here? Ah. Okay, I think ads should be over. So here we can, I just added a to-do. When the token is at the end of line, maybe report until end of line instead of column and byte. Would be just easier to read and say just, you know, you reach the end of the line or whatever. But I will deal with this another time once I restructure the add arrow stuff. Because as I said, I do not like having these strings floating around everywhere in the code to indicate error messages. I rather have them all in one place and then assign error numbers to them. So I can just say add error and then put an error number in here. And then I just have one array where I can look up the error number and the corresponding string to it. Which also has the advantage that I can give my errors numbers similar to what the C compiler does, right? So error C something, right? Something like here. But that is for another time. Okay, and if you just joined recently to watch, I rewrote basically the syntax tree parsing handling, and I didn't quite finish yesterday. I did this off stream, by the way, because I wanted to move a bit forward to the code gen stuff, because I wasted a lot of time on this, and yeah. But I haven't finished it, so I'm going to finish it now, and I'll probably finish a bit early today, but then stream later in the day again, just to hopefully get somewhere with this. Anyways, okay, let's do this. So we have this, right? Skip to next operand. Okay, that is cool. So then here, all I have to say is while skip to next operand is true, right? Consume next operand right here. So as long as we have a next operand, we try to consume it. And what I need to do here is basically, so one, read operand node leaf, right? Then two, I need to say current next equals next operand. And then I need to set current to whatever the next operand is. So that means here I need a syntax node. No, actually, we just need operand t current, right? Okay, instead of doing the casting and stuff, I should have done the same as with my other nodes, where I have this add value thing. So let me quickly add this, right? So is node operand, then we can say node type operand, right? It's just a simple check. Can do that here and say get operand value, right? And then that would be operand t. And then we can do the cast in here. That way, if I ever change the type, I only need to do it here, right? But I mean, not really, but. And this is so small, those will be inlined anyway, so we don't have really a function call overhead. So all I need to do here is say get operand value first, right? So we want the operand of the first syntax node. And actually, I could have the null checks here. Yeah, okay. I leave it like this for now, but it is ugly. I don't like it, but it doesn't matter. Skip to the next operand, right? Okay, so now we need another leaf node. So we say syntax node t, which is the next operand node leaf, Like so, right? So we have our next operand. Then we need to set current next to get operand value of next, right? Except we probably, I hate this so much. Whatever. I see myself getting so annoyed with this that I'm gonna probably do another stream where I go through the arena stuff and try to reason about error handling and see if I can make this better so I don't have to do all these null checks, because that is just annoying. Maybe I can't avoid it, maybe it is just the way it is and I need to leave that in, I don't know, but I'm sure I can maybe come up with something, I don't know. Again, maybe I will even go through the RAD debugger source code to see what they're doing. I mean, I mentioned that before, but I maybe can do that on stream. That would be maybe fun. I don't know. We'll see. And then we just set the current one to current next. There we go. Okay, calling get operand value to get the current, right? We skip to the next operand. We're going to read it. We're going to set current next to the next one that we just read, right? Wait, current next. No. This is wrong. This is wrong. Actually, we just need to point to next because this is a syntax node, right? And then here I need to do this one. So I can just call next. And only this part really needs to check for null. Well, no, actually it also needs to check for next data. It's not null. Oh god, this is so ugly. And this is so error prone. Okay, it doesn't matter. Okay, focus. So we got this going. And then in the end, we just return the first node because this is just a linked list essentially, right? So we just need to return first here. But this loops as long as we have operands available or get to the end of the line. And it handles all the error reporting for us. Okay, cool. So this is it. This is the meat of this. Okay. Cool, so that is operands. But now there also is directives and operations. That is the stuff that comes before operands, right? I put them up here because I actually allowed them to be in an expression first, but then I realized, no, I should just report errors. So those methods are actually not used anywhere, but we can do it now. So we don't need this. Okay, so this is an operand node. Cool. So now we can go into directives and operations. Let's think about those. We have a directive node, fine. The data so at first it was just a keyword, of the directive, but now we need a bit more data, right? We basically also need to make sure that we have the operands of the directives and operations. Functionally, there is no difference between those. So let's just make one struct, directives and operands, right? So type def enum, what do we call this? An operation. Do I already have operation? No, okay, cool. Struct operation. And what we need is the keyword type, right? And then we need an operand node. So syntax node operands. Okay. Then we have operation T, operation. We need the Alexa, right? And then what we're gonna do is say operation T result is get memory arena type Alexa arena operation T. If result is not null, then set a few things, otherwise return results. Doesn't matter. I mean, we always return result. Then result data. No, that's not true. Keyword, right? Is Alexa current token keyword. And then we have operands, which will be an operand node. Right? Okay. And this will build the linked list of all the operands with all the expressions and assign it to a given operation. Right? Now, operations can be in a directive node. So you know what? Syntax node. Nah, I'm gonna leave those separate. That's fine. That's fine. Operation Alexa, right? And then down here also Operation Alexa. I was trying to figure out if I can just have one function, right? Because they're like fairly similar. The only thing that changes is like the enum that we pass in to figure out what kind of syntax node this is. But I think I like this distinction better. Then I have to come up with a name that kind of encapsulates both, and I don't. Okay, is node directive is still true. Okay, is node operation, that is also fine, but we need to change the get directive value and get operation value. What we now need to return is the operation pointer. And that will just be operation pointer like so. And down here as well. Nice. And I forgot to mute my phone. Okay. Apologies. Okay, so I also had this syntax tree that just had the line and then the root node. But the operation is essentially the root node. Labels will be handled differently. They don't go through this path. They will be handled beforehand. They're not part of the tree. Because they're just that simple to do, right? So I didn't bother. I could add them to the tree, but that would be kind of weird. So maybe I just... Nah, okay, I'll leave the syntax tree thing, whatever. It just has the line. I mean, it's already there, right? So why bother? So get memory arena for the syntax tree. We set the Lexa to the current line we're in, and then the result root node will be get operation. Nope. No, what am I doing? It's an operation node, right? Okay, but one thing that I need to do is some error handling in the operation nodes. I just realized. Oh, wait, and also don't know if operation or directive. Oh, okay, yeah, right. So this code needs to go in here. Okay. How do I read the operation? Ah, okay. I remember now. Never mind. So we have is token operation, right? So Lexa current token. So if we have an operation, then the result root will be an operation. No. An operation node. Right. Otherwise, is token directive. What do you mean is token type directive? Don't I have is token directive? Or are you just annoying? I do have is token directive. You're just being annoying. Okay then. Lexa current token results root up no directive node. Okay, and then if it is anything else, I can already report a major error. But then we also would never go into the operand stuff and all this kind of thing, right? That would all just fail. So there I need to skip to the end of the line. So basically to do report all kinds of errors, right? Syntax errors. And we immediately go to Lexa advance Lexa skip to next line. Okay, what kind of state is the lexer in at the end of this? Operation nodes. We then go to operands, and operands already report an error based on this. So I don't need to skip there, but I need to skip here. Okay, so this basically means now, so if we have a valid instruction and then the operands are wrong, we actually make sure that we report errors for every single operand, right? As we try to build a tree out of it. And if not, wait, I just realized. I mean, I add the error. But okay, so what I just realized is, yes, I report errors for like every single operand. But let's say you have something like 1 plus 3. Let's say you have A. No, let's say we have 1 plus 3x, right, comma, 1 plus 2y, right? So this is a valid operand and expression, but then I encountered this error, I would report this error, but the tree in the end, also for this one, but the tree in the end will just pretend these didn't exist and still treat this as a valid line. I wonder if that's a problem. Probably not. What's the worst case that could happen? You kind of... I see, yeah. You might report another error here because we're trying to actually parse that line then, right? So okay, we have an ad coming up soon, I think. I might have to restructure this. What I would rather like maybe is to mark the entire operand as an invalid node. Maybe I can't do this with this error to not overcomplicate it too much. Maybe I should just give up on the entire line and be like, hey, what you doing? Okay, ads seem to be in progress, so I can think a little bit about this while the ads are going. Welcome back, by the way. Yeah, I think I might do it this way. So read next operand. We pass in the current one. And if next token is not separator, then the should use braces here. Then the current expression will be invalid plus report error, right? And then just skip to next separator. If there is one, then get operand node leaf set and return the new leaf. And if not, return the current one. But then there's a bunch of allocations happening because of this expression, right? So damn. Okay, tell you what, I'll do this here. So, U30, no, U60, oh my god, U64, arena position, get memory arena position for the Lexa arena, right? So this is the current position before any allocations happen. We read all the expressions, right? And now is the time to check. So if is token separator from the current token, and if this is false, then we kind of want to rewind, right? So what we're going to do is rewind memory arena to position, arena position. By the way, do I have a block in there so I can't rewind forward? Yes, I do. Okay, I thought about that. So we want to get rid of what we allocated right here, right? Because we have a token separator and we want this to be an invalid node instead. So what we're going to do is then say result expression invalid node, right? Which is right here, and all it's doing is it's creating a new node that is invalid. And what we then can try to do is skip to next separator, right? So we can say well, we want to report an error. Now we can actually do the error thing right here. Essentially this. Right. We can later plug this out in a separate function if we want to adjust the errors a little bit. Like, for example, you also might want to have different errors depending on what, like, open braces and stuff. So maybe add more fine-grained errors. Don't know. Right. For example, if only one error, then just report a more detailed. Why did I do this in a new line? You can just report a new detailed, a more detailed description. So, for example, if the error count is only 1, right? We might want to say you know, if it's, for example, just a close bracket or something, then we might want to say, oh, invalid close bracket on this location. Did you forget to have an open bracket? Stuff like that. But for now, it's just going to be this. Okay, so we read the expression nodes. If we do not have a separator, we wind back what we allocated so far and create an invalid node out of this, right? But only for the expression. Then we move to if we actually have an X separator. If not, this will just be end of line, right? And that is fine. So now let's go to the calling code. Well, we then can say is token separator pardon me. Might take a break soon just to give my voice a bit of rest, and then actually potentially probably end the stream soon-ish. Let's say 30 minutes maybe, I don't know. And then come back later in the evening. In the evening UK time, in case anyone is wondering. Okay, so while we have a separator, try to read an operand node leave, right? Which goes on operand, and it already checks for the next one and loops ahead. So that is fine. And then next, we need to set the current next to next, and if this is not null, then set the current to whatever this is. So this logic is still the same. But now, whenever there is an actual error after a valid expression, so let's say, you know, as I mentioned, we have LD 1 plus 2x, right? Oh, sorry. And then 3 times 4, 5, 3 plus 5, whatever. Doesn't matter, right? So if we have any of these, then this is a valid expression. So we're creating an expression tree for this one, but then we have a trailing thing that we don't know what to do with, right? Oh, if this would be a close brace like this. We then remove the entire thing and say, well, this whole thing is invalid, right? But we still want to parse the other one. Potentially. Because that one might be correct. I don't know. I haven't thought about too much about how to deal with trees like this. And if there's something invalid in here, right? For example, if this would be invalid because we're expecting a binary. The way you would go through the tree is like, okay, you have LD, but then you have an invalid thing, so we stop parsing, right? But we do not need to report an error because this is invalid. If this would be valid, we go through here, we parse this is fine, we parse the next one, we go through the whole expression tree, we encounter something that's invalid, so we give up. But do not report an error because, you know, whatever. I'm not sure if there's a better way to do this or anything like that, but that's what I came up with for now, so it is what it is. Okay, then on operations, like I said, we either have valid operations or we do not, and if we have not, we just skip to the next line. So this is like an early termination thing, right? So basically, if we, let's say, so this is a valid operation right here. Put FFFF into the register A, right? But let's say we make a little typo and, well, it is actually all lowercase, but let's say we have a typo and we say LX instead of LD, right? Then this operation would already fail. This would be considered an identifier that we don't know. So we can now report an error like that, and it wouldn't even attempt to make sense of what comes after this. Which is okay. You kind of have to think of this as like a function call, right? Sort of. Not really, but you know. Okay. I think I'm fairly happy with this. Except, right, the result root is invalid. Right. For now, let's just say add token error with Lexer Lexer file, Lexer current token, and syntax error invalid operation or directive. Right. Report some nicer and more detailed errors, depending on what kind of token we have instead. Right, this is just something so I actually see an error message for now. But that's basically it. So this is how you build a syntax tree. You just call syntax tree, and then it just calls a whole bunch of other stuff. Right? So really the only thing that needs to be exposed is this. So now we can do the tree.c file and move things around. Include... can't even spell tree. Okay, right. What do we need? We need syntax tree. We need this one, right? Whoa. How about I open you next? Okay, we need this. This means we need a syntax tree type, right? I'm exactly doing it the other way around, don't I? So let's copy you in here, and just need the definition here. So we need to hold on to the type. We need syntax node, right? So syntax node is up here. So we need all of this and the enum. We don't need new node. That is just something for the C file. We don't need register nodes. But we need to know about register nodes. So I need to have the definition for this in here. And for this. Same for everything else, really. So, actually, registers, right, immediate values. Don't need this. We do need this and this. Unary operators. Yes, we do need to have access to these types. Okay, let's just copy all of this. We don't need these. Right, we don't need this. We don't need this. We do need these. Okay. Strings and identifiers. Right. Don't need this one. Do need this and this. Identifiers, don't need that. Do need this. I mean, it doesn't necessarily matter. I could just have everything in the H file, because I'm including the C file anyways, but it's still a nice separation to have, even if I just include the C files in main.h, because some of these call, some other ones that might not be defined up there, so the H file then actually might help. I'm not sure, although I'm not exposing those necessarily, so maybe it doesn't help at all. Never mind, it just helps for my mental separation like this, so I'm just going to do it. Okay, brackets, right? Okay, don't need that. Don't need to be able to create a brackets node. Don't need those defines here to know if it's a square bracket or round brackets. That is still useful. And get the brackets value. Okay. Then invalid nodes. Is node invalid, but don't need this. Binary operators, yay. Need all the types. Did I not create? Oh, there you go. I actually forgot to do that. Oh well. Okay, so B32 is node binary operator. Syntax node, right? Return nodes type, whoops. Syntax node type, binary operator. So I need this one. And I need to get the binary operator struct. So binary operator T, get binary operator value. And here we do a quick assert is node binary operator. Right. Return binary operator from node data. Okay. Cool. Expressions. That is a doozy. Expression node leave, an expression node. But expression nodes do not have like specific types, right? So we just take all of this, put that in here. Okay, operands. Operations, not operands. Okay, we need the operation type that we still do need. Let's do it. And we need this. Oh, good, I have these. Okay, I can just copy all of this. Don't need the type, but need everything else. And here we just need that one, this one, don't need this, same here, and don't need that. And potentially, yeah, don't need this. Okay, cool. Finished right on an ad break, apparently. So, but I mean, I'm not doing anything special right now anyways. All I'm trying to do is wire all this stuff in, right? So instead of parser, what we're going to say is include parsing tree.c, right? And the parser will be something else. So let's remove all of this. Oh God, I have more. Yeah, I've been at this for a while. Okay. So parser is essentially empty right now. We don't have anything special there. Symbols. I changed some stuff there, but I think I'm okay with that. Let's see. Build. Okay. Symbols.h. Unexpected token struct. Indeed I did, my friend. Okay. Yeah, build again, as if that will reduce all the errors, right? Actually, I'm losing track now. Okay, CLS build. Right. Okay, Lexa. Yeah, I made some changes to the Lexa as well, but I mean, I only added a few functions, so I'm not sure what's going on there. Let's see. Lexa C. Ah, yes. Yes, indeed. Okay. But wait, that is symbols. I didn't change the hash map, did I? No. I changed symbols, so why? What? Okay, anyways, I have a bunch of helpers that I added, right? And I want to expose those, so let me quickly do that. So these are all new. So we have the enum. We have the token struct. Right, and then we have this. This is all going to be these. Oh my god. You know what? With these I can actually do something. There we go. There you go. Okay, then we have the Lexa advanced, Lexa skip to next line, and add token error. So these things are still good. Oh, right, operator precedence. Okay, so in tree.c, at some point, operator... No, okay. Get token precedence. That's what I wanted to name it. Okay. So U32, get token precedence, token T, token. Right. Let's remove this. And this is gonna be this one right here. And right. I might just steal the precedence from C. Because that is easy, right? Let's just get all the binary operators. I have a function for this somewhere. Binary operators, there you go. Right, so we do this. Return U32 max if it is none of that, right? Okay. C operator precedence. Unary, well, we kind of deal with those differently, so we do not need to worry about that. We don't have indirection and all this kind of stuff. But essentially, okay. Well, we don't have multiple. We don't have modulo. But essentially, divide and multiply will return. I mean, it doesn't matter what you return, right? So as long as they're like in ascending order, it's all fine. Plus minus, that would be return 2. Left shift and right shift, okay. Return 3. Then we have AND and XOR, okay, and return XOR and XOR. Then we have OR. Okay. Return 6. Wait, why is not in there? It's not a binary operator, dude. What did you do? Oh dear. Go away. If it's multiple lines, let's do this. All right. Okay. This needs to go up here. Okay, so that is for the tokens, and then we have the code point stuff and all this shebang. Right, okay, so now let me do this again. Builds, I mean, this won't solve anything. We haven't solved anything, so... right, so why... Again, why? Token keyword, keyword type, that's perfectly normal. So why hashmap item... Hashmap item value is a void. Okay. Truncation from void star to keyword type. Truncation. What do you mean by that, truncation? How would that... Whoa. Why is the store open? What the fuck? I mean, so what? How do I actually store the keywords? Why did I store this as a pointer? That's messed up. Keyword value. We can just pretend that the value is an address, so I will do that eventually. So where was this used? Lexa. Read directive. Oh my god. No. This. Lexa read directive, and we want this line. Bonkers. Okay, well, I'm glad I looked at this again. Build. Hang on. CLS build. Right. Okay, we have a few more Lexa things, which I'm kind of surprised. Right. Maybe not that surprised, because that is actually a new function that I added. So yeah, in the Lexa, I added the ability to read the binary shifts now, and to read, what was it, strings as well. So that is something I added. It's fairly unexciting code, but yeah, apparently I did a few mistakes. Yeah. Okay. CLS build. Internal compiler error. Holy shit, what the fuck have I done? Fatal error, unable to recover from previous error. Stopping compilation. Holy moly. I guess I have screwed up massively. Okay, but yeah, one error at a time, right? So let's right. This is what happens when you work on something without compiling it once, and then in the end you're like, let's see. Signed unsigned mismatch. Why would token type be signed? Are enums signed? I guess they are. Well, that is upsetting. Boop. Okay, now we can finally look at the tree stuff, because that's all new code that it apparently screwed up. Oh, right. Commas, right? In enums, we want commas. Why are you still... Oh, right. Because I didn't clear the screen and I scrolled up too far. Okay. Line 4.2. Syntax error identifier unary operator type T. Type def enum. That's what you want. That's what you want. Okay. Column is not a member of Lexa. See declaration of Lexa. That will be correct, because... but why... Oh, tree C, right. It would be Lexa current token.column current token.position. Cannot convert keyboard type T to void star. Man, dude, just trust me on this one, all right? Just you know, just trust me. Just do a U32, man. It's gonna be fine. It's gonna actually, dude, U64. It's gonna be great. It's gonna be amazing. It's gonna be fine. It's gonna be fine. Right. I probably have to do that in quite a lot of places, to be honest. Where I kind of abuse the pointers a bit. Line 18. Come on, dude. I know it differs in direction. Can't I just... So I thought you're able in a pointer to just specify an address. Oh, can I do it this way? No, you're still complaining. I mean, it is just a warning. I could just tell him to shut up, because that difference in indirection is what I want, right? So I'm just gonna be a little bit sneaky. CLS. I don't need to do CLS anymore. Brain, stop. Okay, I'm just gonna be a bit sneaky and check how to MSVC pragma disable warnings. I don't want to disable it all the time, but I want to disable it, you know, where I know what I'm doing. Okay. No, pragma warning disable. Wait, push and pop. Okay. But then, right, this is only useful if you have multiple ones, which I don't. Okay. Oh my god. Expected new line found separator. Oh, great. Can't even do that without being shouted at. Okay. 3-1. I assume that will be a similar situation. Yep. Yeah, it's a truncation. So what? Will you shush if I do this? Yes, you will. Thank you very much. 3-8. Yeah, that's the same thing again, isn't it? So we're just gonna do that. Build. No. CLS. Build. 5-1. Oh my god, you're annoying. Oh my god. When will I learn? Okay, well, I do this in a few different places as well, so let me just go through this and figure out all the places where I'm doing this, right? So I did this on registers, right? I did this on immediate values, okay. Unary operators. I don't do that there because we have an actual type for those, right? Strings, we also don't do that there, I assume. Yep, okay. Brackets, also don't do it there. This is okay. Expression node. Was that all of the instances where I was doing it? I guess so. I guess so. But why are you complaining on line 61 then? Oh, because you don't know what expression node leaf is. Right on. Okay. Expression node leaf, my friend, is... Oh, man. There. It's this one. You know what? Let's just put it on top. No need for a comment. Okay. Ah! Dyslexia is kicking in. With return. Returner. Oh, my lord. Okay. Cannot convert string to U8. I mean, that sounds reasonable. Why would you want to do that? Oh, because it is copy string and not a string copy. So I have copy string, which takes a string type and copies it with the help of arena into another string type, right? But I also have a constructor, if you so want to say, that is called string copy, right? You create new instances with string, and you either have string, string copy, string format list. And string copy is taking the raw bytes from somewhere and the length from somewhere. So this copy string is just really if you already have an instance of a string and you want to create a copy out of that. It is a bit, naming is not the greatest, but yeah, whatever. We have an ad break, but I'm just fixing stuff up anyway, so... same down here. Copy string. Expression node undefined. Right, that is because expression node is down here. I think the ads should be over now, so but you haven't missed anything. I was just trying to fix the errors one by one, basically. Right, this is precedence, not min precedence, right? Nope. Don't know why I typed run. Result undeclared identifier. Jesus, man. Well, it's good to know that most of the things are just typos. Kind of embarrassing typos, but typos nonetheless. Right, okay. This I should have thought about. But all of... No, not this one. Actually, no, this one as well. Right. Okay, again. So these, we want the address. Same, I think here. Yeah, it's the token pointer. So we want the address. We want the address. We want the address. We want the address. and again the address, and the address, and the address. Oh my lord, okay. Silas build. Okay, we're getting to the internal compiler error. I'm really curious what caused this. I'm really curious. My code is so good, I'm causing internal compiler errors. Right, this is token identifier, not token type. We don't have a is token type. Right, build. We have another pointer. Memory arena differs in level of indirection. Right, because I need to specify the arena. Okay. Still internal compiler error. Okay, okay, okay. Cannot convert from, again, token pointers. Pointers. It's pointers all the way down. Interesting. Again, pointers all the way down. Right. Oh, getting close. Pointer. Great stuff, great stuff. I must have been asleep while writing this. Right. Okay. Keyword must point to struct/union. But it does. Get memory arena type. Oh my god. I had a type def for an enum, but it was a struct. Okay, do we think this was the internal compiler error? Place your bets. I think that might have been it. Yay! Internal compiler error resolved, but we have a bunch of more errors. Okay, cool. That is great. What? Oh, the C file, right. Okay, what do you want here? We don't have Lexa line, that is true. We have a Lexa file line. Okay. Stock is going mental again. Fantastic. Okay, cool. We have a pointer, right? I didn't even think internal compiler errors were possible. That is hilarious. Actually hilarious. Okay. Built. Cool. We only have parse source file error, which is correctamundo, because in main, sorry, not main, but in program, when we run the program, we call parse source file, but that bad boy doesn't exist anymore. Okay, cool. And if we run, nothing will happen because we don't do anything. Okay, but now we could have a simple function to look at the tree, right? So let's do that. Parse source file. We put that back. Okay. Parse source file with memory arena, right? Was that the, whoops. And the Alexa. Why did I pass the arena? That doesn't make any sense. Alexa has the arena, so I just need the Alexa. Let's call this debug parse source file, right? Because that is not the final thing that I want. Not even by a long shot. I just want something, right? Okay, then go in here, void. We have Alexa to Alexa, right? And what do we do? What do we do? Well, we kind of want to a U64 arena position. Get memory arena position, Alexa arena, right? Then we want a syntax tree for every single line of code, right? So line, while, how do I stop? I haven't thought about that, shoot. Syntax tree. And that goes to the next line, right? I have to refresh my memory, hang on. Operands, right? Until that. And then if it is a separator, we just do that again, and then eventually we reach end of line. So we're stuck on end of line. Okay. So while is token end of line, that is a question as well. Hang on. Alexa skip to next line. Does it already? It skips until it has the end of line character. But it doesn't actually advance from that. Okay, but is token end of line also has end of file. So while that's a bit awkward. So, and the line parsing is just with syntax tree. Lexa, right? And then we can look into the line. Right, for right now, let's just make sure it is not null, right? There we go. And then what we're going to do is rewind memory arena to position. Because what would happen here is we would parse, right? And then if parsing was successful, we no longer need to hold on to the data that we just allocated, so we can just rewind the memory, right? Basically rewind the stack. However, if we need to hold on to the tree, which we might have to if we have unresolved symbols in there, then, or maybe we can build like an intermediate unresolved tree out of this. I don't know how to do that yet, but we'll figure it out later in the stream. I will actually stop soon, so. Then we wouldn't want to rewind because we need to hold on to it, but that's a different story. Or we might have different arenas for different situations. I have not thought about it too much yet, but I'm sure it will come up soon. Okay, and once we have done that, we want to say Lexa advance because we need to skip over the new line character, because that's what we will be left with a new line character or with the 0 character, right? And also, for the whole time, what I realized, this little thing right here, next token, right? I don't think I'm using that at all. Like, I'm holding on to 2 tokens at a time, but actually I'm just using 1 at a time and just advance. I've never looked forward 1 token, ever. It's kind of wild. So I can potentially remove that, actually. Okay, then. To do. Remove me? Okay. Right, let's do build and run. Have I, like, lost the ability to code? What's going on? I just wrote this one thing and I already have errors. Oh my lord. What am I doing? Oh, right, yeah. That would do it. What? Come on! Same mistake as before. I always forget to pass in the arena when I rewind. I don't know why. Okay, build, run. That was not a good sign. Because it seems to be stuck. And it's not even outputting the last line. Okay. Run debug. We need to figure out what's going on. From that behavior, I thought... Did I just launch a second instance? Fantastic. From that behavior, I was fairly sure that it's gonna be like... crashing somewhere? Because why would it not print the... like how long we took to parse and stuff? Because that code is already in here, right? Yeah, there you go. Print parsing stats. We never get to this stage. So that to me indicates a crash, right? Wait, what? Oh, I'm bitten by this again. Oh my god, because the working directory is not pointing to the file that I want to. There is our crash. Okay, this is an assert that's being triggered because arena current is 0. Did I just find a bug in my arena code? The one that I've been using for like ages? Why is it all null? What is going on? But clearly you managed to create something. So why? I mean, all the nodes and everything didn't fail, so I'm a bit confused. And it's on the first parsing? What? Okay. Lexa Arena. Well, we have Arena, all right. Arena position. Seems legit, I suppose. I mean, there is some stuff on there already, like the symbols table and things like that, so that makes sense. Okay, syntax tree. We're getting a syntax tree type of the arena, right? Bam. Fantastic. And this is still correct. Okay. We're putting up an invalid node. We're adding an error. And we skip to the next line. Cool. Rewind memory arena to position. So we are in position for 42000. And we want to wind back to 41952. 41952. And indeed we have. Cool, so we're all dandy. Okay, how about Alexa Arena? Oh, okay. This will be interesting. I think I know where my bug is. Because we're close to, I'm only committing a 4 kilobyte page and we're already fairly close at the edge of it, right? So what I'm thinking is at some point I might be committing a new page and then rewinding. And that might invalidate everything. Okay, I never reached this case, I think. I set a breakpoint there anyways, but this is essentially only happening when the data I'm requesting is not fitting into the reserved space, which it should because I reserve like 4 gigabytes right now. But here in the committed stage, so this is where we might have issues, right? And then rewind memory arena to position. Let's see. We get the current position. If position is bigger than this, then yeah, okay, fine. Position will be clamped to the floor. Why? Right, okay, because we do not want to erase the header. Yeah, that's fine. Arena current is the current arena, and then we have previous. So what we do is, while current base position is bigger than this, really, I'm releasing the memory. I think what I want to do instead of release is probably decommit. If any pages in the region are committed currently, the function first decommits and then releases them. Okay, but what does that mean? Does that mean it decommits and then if you call again, then it releases? Oh, we have an ad break. Okay, I think ad break is over, so let me do this real quick. Let's do a build, and then we run. Okay, so now we're getting over the page boundary. So we have arena. That's the current page. So we have 4 kilobytes committed. So data does not fit in committed, but fits the arena. Wait, but this is fairly early. This is when we do the hash map and stuff. So let's just jump over this. This is for the output binary. Okay. Because we're never rewinding here. From now on, I want to check what's going on, right? Okay. So far, so good. Ah! Shit. Well, I mean, arena is still okay, so that's fine. There must be a better way to do this. Well, let's just do that, right? Duh. Okay, so now, page boundary. Okay, 4, 5. Right, so we just need a tiny bit more. What we're doing is we're getting the system page size, we check the end and align it based on the page size, which gives us this number right here. So that is a full page worth. We clamp the ceiling to what is reserved, but that just ends up in the same thing, right? Because we have tons of space. And committed, we have this. So the new size is just one page, which is 4 kilobytes. So now we go to current committed. Right, to get to the right address that is still reserved, we go to new size, we commit the memory and leave it as read write. Okay, and we have new amount committed. Okay. So now arena plus start, current position, as okay. We hit page boundary again, and again, and again, and again. Why are we hitting this so much? What? What is going on? Are we not rewinding correctly? I think we might be stuck on the operand. Yeah. So we're just stuck on the operand. We consume memory. Quite a lot. Okay, cool. In use 5 gigs. Okay, whatever. Okay, so why are we stuck here? Shit. Okay. So we're in an operand. We read an expression. The expression is 0. It's good to know that it added padding, so I kind of need to shuffle things around maybe a bit. Where are we actually? Position 722. Okay, so if we go to Alexa file, no, let's go here. Alexa file base, Alexa file position. Well, that's a new line character. Okay. What's the next one after that? No, that's not what I meant. Oh my lord. Fine, plus 5. Empty? Really? Okay, whatever. We're on a new line character. Okay. So expression node. If we have an expression node leave, what we're doing is we're returning a null pointer, right? So but here I mean that is null, right? So okay, we have a null pointer, and the current token, if it is not a separator, we kind of want to rewind to 2551824, and this is 2551824. Right, it didn't consume any memory. Right, okay, that makes sense. Ah, shit. Wait, what? It is a comma. Alexa current token. Whoops. It is a comma. It is in line 48, that is correct. Column 12. Column 9, but this says column 12. Line 48. So we're here. Okay, so there is a comma, space, a 0, and then a new line. Okay. So we're at the comma. Right, 12 makes sense because that is the next token that we're about to read, so that's why. I think. No, but it's the new line. Why is it the new line? That's so confusing. Anyways. So result is, well, an empty expression, right? So an empty operand, I mean. Okay. Oh. Oh. Uh. Yeah. Okay. I have forgotten to swallow the comma. So we might have been stuck in an infinite loop somehow. Yeah. Well, I'm glad it's not a problem with the memory arena. Although that was kind of curious why everything was 0. But yeah, essentially for every single line, we now get invalid operation. Well, not for every single line, do we? Let's see. I mean, yeah, this is all bogus. So invalid operation or directive. Again, this is the one error where I want some more error messages, like some better ones. So it will report what it actually encountered instead, but I just wanted to get it to work now, so I haven't gotten to that stage yet, right? So these are comments. This is fine. Alias, right? That doesn't work. Unknown directive alias. Yep. Why is there line 30 in the middle of it? What is going on here? Ah, I know what's going on. The this error right here. I might have an invalid token, right? And this one should actually be ignored. So I can just say else if, no, actually, if is false, is token invalid, the address of the current token, then we print an error message. Otherwise, we just ignore. Actually, still a bit weird. So line 31, unknown directive alias. That is correct. But why line 30 is saying invalid? Is it because it's empty? Did I not think about that? Hang on. Yeah, I mean, if is token end of line, then we just might want to return a 0, right? Because, yeah, we don't want to do anything, right? So maybe this should even be the very first thing. How about that? Uh-oh. Right. Of course, this fails because I had an assert in here. So it's just silently crashing. Right. There we go. Now it's correct. Okay, line 48 is curious. Why? Because it says invalid operation keyword LD. Operations can only appear at the beginning of a statement. I mean, that is as much as the beginning of a statement as you can get. So I don't know what it's doing there. So let's debug this stuff, right? And we can do this by going in here. Actually, did I not just change that? I did, okay. Why is it not reflected in here? close you. Build run debug. Stop. Switch to this directory. Go again. Remove this. Okay, we go in here. This is fine. Go to syntax tree. Go in here. Set a breakpoint. Give it a condition, and the condition will be if the Alexa file is on line. Which line was it again? 48. Right, so that is our condition. We've hit that condition. So let's see. Wait. No, that was not it. Now we have reached it. Okay. Wait, this is the new line character. Oh my lord, what the hell am I doing? Okay, whatever. So doing this, right? We advance. Now the current token is the actual keyword. Okay, so go in. Okay. Create the results. Have the line. Is token an operation? It has a keyword LD, so it should be an operation, which it is, right? So we go in here, operation node. We're creating a new node. Then we're trying to get the operation data, right? Which is the keyword. And then we're trying to read the operand node, which, genius. I forgot to advance. Line 66, column 8. Yeah, we don't allow that. That now changed. Okay. Just waiting for the ad break to end before I continue. Okay, ads should have ended. Now, so this seems to work. It actually can, I mean, apart from like some directives that it doesn't know about because I haven't added them yet, right? It seems to be reading all the operations fine because I can no longer see that it says, well, except these invalids right here. Right? So let's go on 4.6, which makes sense because we only have a label and then nothing else, right? Although it actually shouldn't report an error there. Okay. That I need to check into because it works here but not here. Oh, because I'm not reading labels yet. Right. So every time there is a label, it will complain. But labels is just something that, you know, is easy to add. But it shouldn't be part of the syntax tree because I want to resolve these label definitions immediately and just put stuff into the hash map. And then whatever comes after it is part of the syntax tree. Okay, but you could fix this, right, with, let's say, okay, we have alias here, right? If I now were to go into my definitions and say, boy, we have an alias, right? And I have to use capital letters right now. All right, just put it in the definitions file. Build and run again. And as you can see, the errors still appear. So we did a great job. What? Don't tell me I have to add them with the bang. Okay, I have to add them with a bang. Yeah, that's okay. That's all right. Tiny bit annoying, but it's okay. So yeah, so if we put in the alias, the errors disappear. Same for data, right? And then data, build, run. There you go. No more data errors. So we now recognize the data directive. Of course, we're not doing anything with it yet, right? But hey, this is kind of cool. So unknown directive header, fine. We could add that as well if we wanted to right now. Those are not final, right? I have to... what? Line 6, line initialized but not referenced. Why did I not see this before? Parser C. Line 6. Oh, it's this one. Unused line. Okay. So yeah, header now disappeared as well. And now we just have like this generic error message, which will get better, but then you already have stuff like on line 4.1. I have a feeling this line is wrong. It's actually line 39. Because if you look at that, we have the operation or directive, and then we want to pass operands. So we read the first operand, which is tile, which we know, right? But then there is no comma. So everything that comes after it is recognized as a trailing token. And in this case, it's the trailing token hello. And if you look where it starts at column 14, which, look at that, column 14, one invalid trailing token until column 21. Let's see. Indeed, it ends at column 21. So something in my line reporting is screwed up. Okay, let's go to the error that is on read next operand. I'm a bit confused why the file would already be so far ahead here. I know why. Because, yeah, because we're having another token that we're buffering, and that token is after the new line, right? But it is a comment. Comments get ignored. So what's happening is, so this is the current token, but we're also reading the next token. The next token would be a comments. Comments get ignored. New lines get ignored. No, new lines don't get ignored. And this is why we are already on line 41 in the file. Not in the tokenizer, but in the file. So really what I want here is not the line of the file. I want the line of the very first token, or even the current token. It doesn't really matter. So really, I want this. What we could also do is just really have a token, right? And just copy the whole token. That would also be possible. So we can just say Alexa current token, right? Let's just copy it. Start token. It's just a few bytes anyways, and we're going to remove some of the things. So that's the current token. We have the start token. We do our thing, and then down here we can just say add token error, right? We still need the file because we're reading the source file name out of it. Actually, it's just going to be file name, I think. And then we have the start token, right? But we need the address of it. And then we can just have this. That way there's less of a chance for us to screw up, right? So, well, that's a good start because I was having my C# brain on. That's funny. File name. Okay, what do you want? You want the source file. Okay. Okay, get the source file. There we go. No more error on line 41, but now we have the correct error on line 39. So right here, where we say one invalid trailing token until column so-and-so. Now, I had a to-do for this. If there is only one trailing token, we might as well say what kind of token it is and print it out. Maybe we can say invalid string after operand so-and-so. Did you mean to place a comma there, right? So we can give some more helpful error messages, basically. But for now, this is good enough. Okay, so unfortunately, this took way longer than I wanted to, so I'm not sure I'm going to be doing a stream later, but maybe I can do one at the end of the week or something, or maybe even tomorrow. We'll have to see. But today, I kind of have to edit my YouTube video. I've been pushing that back for a long time, and I really want to get it released, so I'm going to work on this. And then next time, hopefully, I have enough ready to get into CodeGen and parsing the tree, right? So we now have built our tree, and then it is time to parse our tree. I could kind of verify the tree if I wanted to, right? So we can look at something just to see if it is correct. Let's pick a line. Line 37, right? Let's do this one. Line 37. So go in here. Say condition. Lexa current token dot line equals 37. Right. Start. Let's remove these. What? Why is that taking so long? What? Don't know what that was. Right, go to this file. What's going on? What's happening? Why is it getting stuck? It can run. So why is it not able to run in the debugger? It just chokes. Oh, not running right now? Okay, fine. Okay, again. Run program. Parse source file. Syntax tree. Okay, stop condition. Lexa current token line 37. Fuck knows what that was. Okay, but essentially here we're going to build a tree, right? So let's just jump to the end of it, and then we can have a look at the tree just to see if it is correct, right? So we can have result. That's the tree we're going to return. And so this is line 37. We have a root node, which is a directive, right? Now, what kind of directive is this? Well, we can say result root well, we know it is a directive. Data, and we can cast this to a directive T, right? No. Why not? Can I look at types? Types. Ah, right, you don't know the type defs. Okay, that's fine. Let's say directive. Struct directive? No. Well, that is upsetting. So if I cast this into U8, then it just works, right? So why not? Oh, because it's operating. Oh my lord. Yeah. Okay. I screwed myself over the operation T. No. Do you need operation? Yes. Okay. That was it. So, okay. We have an operation. We have a keyword right here, right? That is number 22. Whatever that is. I mean, we can look it up with G keywords 22. Keyword data. There we go. So this is the global keyword table, right? And if we look at type 22, there we see it's an alias. So that works, right? So then we can go into the operands. We have a syntax node type operand. And, well, this is going to be fun now. I don't know if you can... No, you can't do that. But maybe we can get the address and be a bit cheeky. So we can say operand. There we go. So we have an operand with an expression and a next, right? The expression itself is an identifier. And we can figure out what kind of identifier by taking that address and looking at what would that be? It would be a string T, I believe. String. Yeah, so LCD-CF on, BG on, right? And if we look into the source file, that is indeed what it is. So we have the alias, we have LCD-CF, BG on, right? Whoops. Daniel, brain, work. Okay. So that is our operand. Then we have next, which is an identifier, and then we have an operand. Why do we have an operand? All right, it is the next operand in the list. Apologies. So if we look at the next operand, right, we can just do it like this. Then we have a syntax node type invalid. And why is it invalid? No one fucking knows. Why is this invalid? Okay, clearly my tree is not correct. Column 3, 2. No. No, 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 no. What? Okay. Next. This is the next operand. It starts on column 2, 3, which is the beginning of this. So, if we look at that operand, okay, now I'm stumped. That's already a great start. Great start. I've invalidated something that should be absolutely valid. I mean, this is a fine binary number. That should just work out. And indeed, if we look at 3.7, right, there is no error for this. So what did I do wrong? Oh my god, I'm invalidating everything afterwards. No. Oh. Fine. Okay, clearly I need to spend a bit more time on going through this. But essentially, yeah, the operand invalidated everything. And I'm now worried, like, okay, if one of the expressions is invalid, what do I do then? Because then I'm invalidating it again, which doesn't make any sense, right? So, really, this needs to be in a separate function. And then I need to, yeah, okay. To do, move this into separate function and handle proper error cases. Right, okay. But I really have to stop now. Oh, there's an ad break anyways. Okay, cool. Okay. I don't know about this change. Oh, this should have gone into the other commit. Whatever. Then in Lexa, I think I did a lot. Yeah. What did I change in the last line? Oh, right. Okay. Right. What else do we have? Symbols. What did I change in symbols? Okay, not sure about that change yet. What did I do here? Sure. Okay. And we want the parser. And what did I do here? Yeah. Okay, cool. Thank you. Okay, well, so the new tree parsing is in. Again, there probably will be a lot more errors that I figure out once I actually do the parsing of the tree, but we're now building an abstract syntax tree, which hopefully is more or less correct, although we have seen some instances where it isn't, so need to look through that. But yeah, I'm gonna call it a day for now, and then next time parsing the tree and actually spitting out code, hopefully. So although there's a few more things that I need to do, but I think I can stream tomorrow, which is kind of out of schedule, but I kind of want to do that. So, because this is really fun. We're slowly getting to a stage where I can actually have something properly running, which not too bad. Took a long time, but hey, it is what it is. Anyways, yeah. I really want proper errors for these. All right. That's it from my end. Thanks for watching. See you next time. Again, not today, but tomorrow, hopefully. Probably, maybe I can stream a game tonight or something. I don't know. I feel like I want to play a little bit. But I need to edit my video now, so bye. Buttons. Where are the buttons? The buttons are here.